Joseph is the VP of Engineering for Liveline Technologies. With a PhD in mechanical engineering and over 15 years experience, Joseph has been helping drive innovation in manufacturing. So the presentation today will cover the topic of advanced process control for manufacturing with AI agents. Over to you, Joseph.
All right, thank you. So thanks for having me. This is my first time, I think, presenting to the group. I'm really excited to share with you guys Liveline and sort of the journey that we've had for the last few years, especially with the AWS side of it. So we are part of the SaaS factory. We meet weekly with AWS, and I'll get into all the fun stuff that we went through in the last couple of years. The talk today is going to be about advanced process control using AI agents. Essentially, we've taken the state of the art in which you do agent-based machine learning, your neural nets, and all the fun stuff that you can do with reinforced learning, and really created a product around driving autonomous machines, I guess, or continuous process control, basically using a software layer. Now, what I'll talk about today, I'll talk about our mission. I'll jump into how our tech works, a very high overview of it, and then spend the rest of the time really focusing on what AWS did to accelerate us and to get us to market as fast as we can get there. So our mission. So I'll take a step back and really sort of paint the picture here. Behind me is actually a shot of our tech center in Livonia. Liveline is actually formed from a large OEM, Cooper Standard. They provide different components to multiple car manufacturers. So it's a really interesting use case to talk about both automotive and manufacturing at the same time. When I first started down this path, we attempted to buy the technology. We attempted to find anybody who could do very simple controls like this. We say simple, but I mean taking a line and running it. We found there was really nobody in the market that could do something that was, should say, easy to implement. A lot of it has to do with the fact that traditional APC, or advanced process control, really was designed out of the 70s, has a lot of the influences from large refineries and large systems. And a lot of the tech out there was either required a lot of engineering time or a lot of development, or was very narrowly focused to a single piece of equipment. So what Liveline has become is a company that creates and sells AI-based controls at the software layer that does real-time in the feedback loop controls on your process line. The advantage that we are an AI first company is that everything we do is focused on trying to get a new model out to you guys as fast as we can. I mean, every time there's a process change, those of you that do controls know you have to go back in, adjust the PLC or adjust set points, and really have to hand tune it, lots of engineering time. We take a different approach. We take the data and we allow the AI, quote unquote AI, to tell us what the critical signals are and tell us what needs to change in the model in order for us to have controls. We are currently focused on continuing manufacturing and batch processes, and because we've focused on getting to small and medium-sized companies, I think you're going to find that the way that we're doing this allows anybody to attach a machine, get the data flowing, get the controls flowing, and really begin to see the benefits of AI. So we talk about democratizing AI. This is one of the pathways to it. So from the business point of view, why does Liveline think that there's a market? Why do we think we can get out and have some fun? We are offering a low-cost AI automation solution. Traditionally, the refineries, the petrochemicals, you see chemical production, very large systems, very large, states that have to be maintained. Anytime you do a new refinery or you change the process or product or raw materials, you have to go in there and tune the entire machine. If you talk about it from the small manufacturers, there's not a lot of machine to machine or unit to unit communication or controls. Each one of those tends to be part of a recipe system. And a lot of you can talk about the MES, and we can talk about SCADA systems and how we can tune everything together and make controls, linear in nature. But how do you get it so you can do set point controls based on changes in the system from upstream, like materials, or maybe your machine's slowly getting out of calibration. Can you adjust for that without needing to bring the whole machine down for a PM? Some of the largest areas of growth is the small and medium manufacturers for us. So you can see their total available market, sorry, of around $7 billion. We believe that if we can start to hit those markets and really get some penetration there, that we can actually make some disruptive technologies in some of these traditional manufacturers. We also know there's a big push to bring everything on site or back to the US. So this is another way that we can hopefully seize this opportunity and really start to do advanced controls here in the States. Why we think the market's available to us, low cost. Our cost implementation is really just connecting the machines up, getting it into our data lake, we'll call it our data model, and attempting to mimic what the process engineer and the operator are doing on the line. As soon as we have that formulated and ready to go, then we let it run into auto mode, where they're doing real controls for you. The human is watching the line, make sure it's not catching on fire, but most of the time they're just reading a newspaper or feed materials or doing other high value work. We'll talk about on the next slide, but keep in mind that the shift in the thinking here is that instead of going from a SME point of view, where you have to be an expert in ethylene cracking or an expert in extrusion, in order for you to do controls, or you have to fly somebody in and helicopter a whole team in order to get your whole process in place. A lot of what we can do, and our IP is built around this, is to get the data, get it connected, and do as much as we can from a remote position so that we can decrease the cost and the service requirements as much as we can. Again, our whole objective is to get as many companies on the automated control as possible. How it works. Now, I don't have any pretty slides on that. If you want to contact me later, I can walk you through the whole process, but essentially it's 3 steps. It can be done in a matter of weeks. It does not take months or years or stages. It's literally, if you're already a digital company, we come in, connect our box, and we can start pumping data out. If you're not a digital company, we help you digitize. You get your data coming off the PLCs. We attempt to get it into an abstracted layer called the OPC layer. I'm not sure if anybody knows OPC UA, but it's very generic communication space. We then take all that data out. We pump it through our models. We try to determine what's going to be the best things to control over. Those in manufacturing may know that there's time scales everywhere. So you have, some things react much quicker. So ovens are going to react slower. RPMs, I'll just talk about extrusion for a moment because that's what Cooper Standard does, reacts much faster than ovens, which reacts much faster than the blowing agents maybe in any of the other processes. So when we think about what's critical control, we attempt to find those that have the fast moving parts. At the same time, we're also looking at the long term, things like oven drift or things like pressure drifts, especially if it's tank or batch formulations. There's a lot of different processes in there that have these timescales that move over time, and we're always monitoring those. So after we agree on what's important, we then train our AI agents to both do controls and what's called a physics package, which is essentially a virtual representation of your machine. It's not a digital twin in the sense that we have the parametric values everywhere and everything's one-to-one. This is a machine learning dense model of what we think the machine will do if we tweak this knob. What should the machine respond to? And that allows us to do a couple of things. It allows us to run all of our control systems in ghost mode, which is our way of initiating our process so that you can see how the controllers would act, so we can validate it before we actually let it loose. Once we say, hey, let's go, our real-time agents do the controls for you, literally changing the critical inputs that you want changed to control your process. So if it's speed, if it's material rates, whatever it is, we can change those on the fly for you, just like an operator would. Just like a human with an HMI touching buttons, that's essentially what our controllers do. At the same time, we have a virtual sensor, which is monitoring the snapshot of your machine at the state that we took it in, looking for drifts and changes, which means if you have something really odd happening, or you've changed something on the machine, like you've changed the die head and didn't tell anybody, we can alert the operators right away that this is not controllable. There's a lot of things that happen in plants. Those in manufacturing know you can change a cutter or a machine out real quick and not tell anybody, and it's still running and ready to go. You can go and tune a feedback control somewhere, not tell anybody, and again, now it's acting different. So we have the ability to really quickly turn around models and really quickly turn around what your machine physics look like. So the core IP that we have here is, we have quick turnaround times on our models, and we had the ability to bring in small sets of data. So we can get models going over 1 or 2 days of runtime instead of it being months and months and months of years of trying to do linear controls where you bump something, watch it, how it changes, bump something, tune it again. We're basically tuning it all at one shot. Now, the exciting part is that when we deployed this throughout the parent company, we've seen some really incredible results. We're talking about a company that has thousands of SKUs, thousands of parts that change maybe from material inputs, material outputs, whatever they happen to be, changes to the design. Because let's get into automotive supply, we know, changes happen. Basically, when we have deployed these, we can spin up and throw out models fast and get them back down to the machine as fast as possible. We see in some cases, especially in these complex valves here, you can see multiple materials. All right, a micro dents or a sponge, might be a micro dents in the dents or a show surface, an interior carrier here, where we can get variations down 40%. That leads to scrap being 30, 35%. That's our target actually is 30%. It's fully automated. You start the machine up, you get it tuned in, and then you just let it run, and we just adjust everything for you. Let's see. The biggest challenge that we have in any of these machines here is materials, right? The machines we can tune, material inputs change a lot, and so that's what we account for. And I keep saying a lot, but what you'll see when I demonstrate the AWS scheme here is that each plant and each machine is treated as its own individual unit. It allows us then to make sure that parts change, or parts when they change from machine to machine, or when anything is interrupted or disrupted on the machine itself. Again, we can call that back and let you know, hey, there's an issue here. We can't run controls, or running controls, but we may not be able to meet your targets. Please let a human intervene now. We have plenty of communications, alerting, and a lot of that's all done through managed services through AWS. So just like traditional MES and SCADA systems, you want an alert that something's bad, you're out of material, there's a hiccup somewhere, anomaly that comes through. All that's built into the Liveline platform, along with controls. So we don't allow massive jumps. We don't allow the AI to be trained wrong and say, yes, go from 0 to 100 RPM, or cook the oven up to 12,000 C because, it'll cure faster, those type of things. We don't have that. We have it based on physical limitations. And then we basically allow the AI to target a very narrow gap to what the process can handle. All right, now the hard pivot. So how did we leverage AWS? I want to say thank you to AWS because we are part of the SaaS factory. And behind each one of these orange boxes is a few thousand hours of development, especially early on. So we got a product in mind. And again, we were coming from an industrial company. How do we create a scalable SaaS-based company that can go out and get other customers and be just as resilient and reliable as it is in the parent company? That comes into the architecture, design, and scalability. How wide, how horizontal can we actually scale this, and how fast? And can we do it in a way that's cost effective? We have spent hours talking about auto scaling groups and rights and everything that's needed from, how do you sign up a new customer to how do you actually delete a customer? Maintaining a security footprint because we're in a plant. We know security is probably one of the biggest concerns that we should talk about. Knowing that we can control a machine remotely sometimes doesn't give you that good feeling, warm and fuzzy feeling that you get when you're on a plant floor. So we have lots of checks in place. We can enable and disable it from the HMI. We can do it from a cloud-based tablet or machine. We can do whatever the customer needs, but we have safety and security in mind, number one. Because we're using AWS for pretty much all of our and everything we do, we even have them managed black boxes through SSM, and we have pretty much AWS top to bottom. We can manage our global infrastructure from a single location. Oh, sound's coming out. And because they have a global infrastructure, we can target plants in other areas. So we can go to Europe, we can go to South America, we can handle East Coast, West Coast here in the United States. We can handle any place that needs to be in Canada or anywhere that has different restrictions. We know Europe has different, data type restrictions as other places. And so it gives us the ability to really quickly adapt to what the market requires, no matter what the customer is. And then advanced managed services, we have use a lot of managed services, just like the previous presenters have said. As a small team, it's really hard to dedicate people to trying to maintain and upgrade all the core infrastructure. So it was a no-brainer for us to really utilize all of AWS's infrastructure. Everything from the RDS, the SES, all the communication layers, Lambdas, step functions, all the stuff that you would think is easy to do. It is when it's your own computer and your own small little hardware, but how do you scale fast so that you don't have to have somebody manually deploying containers from a keyboard? In the next slide, I'll jump into security and compliance, but without them, we would never have gotten to where we are. I want to actually call out the fact that we're using Security Hub and GuardDuty. We're using that and essentially logs to have validated our process so we could become basically a SOC 2 compliant company. And that'll be on the next slide. So because we are touching machines, we have to have a hybrid or an on-prem deployment approach. I think some of you have already seen maybe the Greengrass gateways or the ability to connect through maybe MQTT or some other places from an AWS managed device into the cloud. We took a slightly different approach because we're trying to be a siloed SaaS company, meaning we have a bunch of black boxes coming on your floor. The data is flowing in. Again, we connect to your devices, pull it into a pool, and from the OPC layer, we convert that into our own process. And then we use a zero trust identity management to send all your data up to the cloud. Each one of the customers gets their own account. So even though you have a shared front end to get there, all of the resources are siloed. That prevents cross-account talk. It prevents any type of security that comes through, any firewall manipulation or any way that you can try to get to resources by using redirects or anything within the browser. And because of that security model, each customer can walk away knowing that their data is siloed. It's their data. It's encrypted. Whatever way that they want their data to be stored, we can store 30, 60, 90, 100, whatever you want your data to be. We can share it back to you. We can burn it. As long as we have enough data to do models, we're perfectly fine with whatever the data requirements are for your company. And because of this, it also allows us to get to small, medium-sized companies who may not actually have a cloud instance or a cloud account anywhere, or don't have an ERP system or anything that is a data lake that they can get to. So we come with both the approach that your data is your data. We can implement within a large company and within your boundaries, and also within small companies, and create their data model for them. The SaaS bridge, the silo model, this is a unique challenge. A lot of places will either have a silo model where you have, your name dot whatever the service is, in which all resources are yours, or a complete SaaS model, which is one interface, shared logic amongst everybody. We approached the harder model, I guess, the SaaS bridge, because we felt that in order for us to offer the security that just talking about, we have to really ensure that the data maintains itself within the customer account. One of the, again, concerns that CIOs have brought to us and talked through is that the data is mine, it's trade secret. There's a bunch of information in there, recipes and everything else. How do I maintain and make sure that my data is safe? And this is what we do. We have single tenant isolation. We allow not only single tenant, but we also allow per plant or per location user support or user management through their role-based access control. We have a zero trust communication, so it's not a VPN. This is a app per app, port per port mapping that goes over 443, so it's already secured over the common open port, so you don't have to reopen anything on your own network. So we can keep a security model on your OT network and IT network that are standard. And that has led to basically our ability to document everything we've done and maintain a SOC 2 compliance. Last slide, I promise. Lessons learned. Cross account rights for silo deploys. Most of us that do development know that we like to have a dev QA in prod environments. So how do we then do those rollouts to customers or updates? How do we actually create a access from the customer account into production versus making sure that we're not deploying anything that's from development into a production site? How do we maintain that only it's directional in one ways within the cross account rights? How do we automate deployments, especially with a zero trust connector? We've used a lot of Lambda functions. We've used a lot of step functions, and again, really appreciate the ability to have all these managed services that are running, that are load balancing for us and the firewalls for us, everything that we need to basically scale a new customer as fast as we can. We've talked a little bit today. I've heard some talks about SageMaker or some other ML processes. Because we're using agent-based, because we're using some bleeding edge models, we actually create our own MLOps alternative only to meet our needs, because we have a lot of moving parts. We need to train fast, deploy fast, validate fast. We really took advantage of the knowledge set that comes out of the SaaS factory, especially when it comes to step functions. How do we do triggering and business logic to know that we need to update or train models or move it to another line or deploy or have questions pop up for customers, should you deploy this or not? Lots of event bridges, lots of communication layer, SES, SNS. I could ramble all day about the services we have, but again, we are a complete Amazon house, and I can't thank AWS enough for all the work that they helped us put through within the SaaS factory. So with that, I will open up for any questions.
Awesome. Thank you, Joseph. It's really great to see how Liveline is leveraging AWS services for your deployments. That's awesome. Before we jump into the Q&A, reminder to check out the survey poll. Please submit your response in the WebEx. It's appreciated. Any questions from the audience? Feel free to put them into the Q&A or raise hand. Looks like we do have one question here, Joseph.
All right.
From Sabarna. Is it possible to deploy the solution on Greengrass too?
That's actually one of our Q2 goals. We actually have a Greengrass POC right now. We're trying to create a lighter version for almost a gateway deploy on the customer site instead of such a heavy, beefy machine. So I will say yes, we've done the POC with containers and the communication layer we need. The hard part for us is the OPC layer. Sometimes that is a tricky layer. If a customer doesn't have an OPC, we have to provide one for them, and that does require some beefier machines to connect to it. But yes, we can do Greengrass.
Awesome. Joseph, I have one as well. Well, I'll pause as a follow-up question. How do we see the deployment in discrete manufacturing context?
We have not done the discrete in large chunks, so that'd be a very good place for us to test out. The deployment is still model based. And so as long as the data is coming in and you're telling us, and we know what the critical signals are and where the critical signals need to be, which is like your measurements. Any device we can get a measurement off and we get inputs on, we can control. If it comes to things like movement or packaging, we have not attempted that. This is more of a batch, as in, chemical batch processing, or continuous as like an extrusion or roll-to-roll processing. But I'd be love to take that conversation, after this.
Good. And then Joseph, I'm curious from your experience, how accepting are factory facilities in turning over a plant to AI rather than a human? And then how do you manage that?
The hardest part for any person that is not digital, any plant that's not digital first, is understanding the limitations of digital and then what the humans can do in that hybrid interaction between the two. We have had success in every plant we've been to because we try to guide them into it, right? Here are your screens with the analytics. Here are your screens that are digital. Here's how you're impacting it. So when you turn it on, you can see this number turn on. We also do things like the ghost mode. We can watch the controls running in the background, and then we show the operator, what would you do? That's what it wants you to do. You're going to do it. And then when we turn it on, we watch it. The operators are sometimes skeptical, but then when they realize the additional time saving they have, they love it. It's the don't turn it off scenario as soon as we get them over that hump of trust.
Makes sense. Any other questions from the audience? Just a reminder, please take a moment, fill out the survey poll in the WebEx. It'll be up there for another couple of minutes. But yeah, thank you, Joseph. Really appreciate your time today in presenting.
I appreciate it, guys. See ya.